Okay, so now we have the definition of a derivative. Derivative, I cannot express to you, this is going to be one of, if not the biggest words in Calculus 1 course that you're taking. A derivative is like the cream of the crop. What's a derivative? It's written as f prime of x. See that notation right there? F prime of x. A derivative is quite simply the slope of the the slope of the tangent line. Derivative is the slope of the tangent line. It's no different here. There is a typo here just to let you know there should be an equal sign in here. So what I use is the limit as h approaches 0 of f of x plus h minus f of x all over h. They use delta x's, I use the h's. I don't care if I see delta x's on your paper for work or the h's. If you follow the textbook, you're going to be using delta x's. So what have we learned? We've learned the following three things. We've learned that the slope of a graph at a point is the same thing as the slope of the tangent line at that point, which is the same thing as the derivative at that point. So derivatives, we're going to be learning how do we find derivatives using rules instead of having to do this limit process. We'll start that as early as next section. How do we find derivatives and what does it mean? And remember, all a derivative is the slope of a graph, and a slope is just a rate of change. So derivatives are slopes, which are rates of change. How is something changing? Very, very important when you come to real-world examples with business. How is my cost function changing, or my average cost function changing? How is my profit changing? How is my revenue changing? How is global warming changing? How is all these different things? What's the rate at which things are changing? More specifically, in hitting at home right now, what's the rate of change of the infection rate for COVID-19? Is it going up? Is it going down? What's going on? So rates of change are extremely important in real-world examples. Analyzing rates of change is the same thing as analyzing derivatives. Okay, so derivatives, very, very, very important concept that we're going to be learning. There's multiple notations that you're going to see for derivatives. The most often is f prime of x or simply y prime. But you might also see dy dx, that just means the derivative of y with respect to x. There's that y prime, which is the same as f prime of x. Another notation you might see is d dx, that means the derivative with respect to x of the function f of x. And another notation you might see is that capital D with a subscript of x, which just means that d is the derivative function. So you're finding the derivative of y with respect to x. Okay, so all of these notations mean the exact same thing depending on the textbook, depending on the problem. You're going to go through all these different notations. Just know that every single point in time they're saying find the derivative, which means find the tangent line, find the slope of the tangent line, which means find the slope of the graph. Derivatives, slopes, rates of change. Okay. So the next example says, finding a derivative using the definition of derivative. Anytime it says using the definition of derivative, we need to use our limits. So it says find the derivative of f of x equals x squared minus 5x using the definition of derivative. If you've taken a calculus before, it's very, very easy to find the definition of this. This is a simple power rule, sum and difference rule, constant multiple rule. The derivative of this is 2x minus 5, so the slope of the tangent line, that's the answer. The answer is going to be 2x minus 5. If you've taken this class before, it's very easy to get to that answer. And I'm going to teach you guys how to do that derivative that quick in the following sections. But what I want you to notice here is this one specifically says using the definition of derivative. This means you have to use the limits. You have to do the long process. You can't use those cheating rules that we're going to learn in those next sections. So you have to do limits or you will not get credit on this. So anytime it says definition of derivative, what I should see is f prime of x is going to be equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. Again, that's our definition of a derivative right there for us, okay? Now, I'm going to teach you guys to do this a little bit differently. We did it the previous way where for the first thing we did was we found f of x plus h, for instance, and then we subtracted off f of x, and then we factored out the h, divided everything by h, then we took the limit. Well, I'm going to start doing this all in line. I mentioned this on a previous page. What can we do in line? We could do this all at once. So what this is equal to is the limit is h approaches 0. And if you want to do this in separate steps, like we've been doing this whole section so far, by all means, please do. You're getting the exact same thing. But I'm just going to start advancing my level of work a little bit. So f of x plus h, what would that look like? Remember, we're doing f of x plus h. So really, let me put this in red parentheses to show you kind of what I'm doing. Right now, I'm doing this part of the problem. So f of x plus h would be x plus h quantity squared minus 5 times, instead of x, I'd have my x plus h. So that's f of x plus h. Now I need to subtract off the original function. I'll do that in blue. That's f of x. Well, the original function is x squared minus 5x, okay? Remember, those brackets do act just like parentheses, so we do need to distribute the negative. And then all of this is over h. So before, we've been doing the red part first, then subtracting off the blue part and simplifying, then dividing it by h. Now I'm going to do everything all at once. Okay, so this is the limit as h approaches 0. Notice I have to write it every single time now. Let's go ahead and FOIL out that x plus h squared right here at the beginning. X plus h squared is x squared plus 2xh plus h squared when you FOIL that out. Now I'm going to look at the next part. I have that minus 5x plus h. I'm going to take that minus 5 and distribute it through to both of them. So that's going to be minus 5x, and then it would be minus 5h. I need to look at the top of the next part. I have that negative sign. So I'm going to distribute that negative to the x squared and that negative to that 5x. Let me go ahead and show that real quick. Distributing the negative to both of those terms. So that would be a negative x squared, and then subtracting a negative 5x would actually be adding 5x. All of this is over h. So I need to do this one step at a time. I need to be very careful here. You can't do too many steps at once. So here's a minus 5x and a plus 5x. Here's a plus x squared and a minus x squared, so those are going to simplify out. So I have equals the limit as h approaches 0. I would have a 2xh plus h squared and a minus 5h left on top. On bottom, I still just have h. Well, I notice that I'm able to factor out an h there. If I'm able to factor out an h in the numerator, and you must factor it first before you simplify, 2xh divided by h is 2x. H squared divided by h is just h. Minus 5h divided by h would be a minus 5. So there would be the factored version of the numerator, h times the quantity 2x plus h minus 5. All of that's over h. I simplify my h's. When I simplify my h's, I'm left with the limit as h approaches 0 of 2x plus h minus 5. So had I done the 3 steps or 4 steps like I did on the previous page, or on the previous way, this is exactly what I would have gotten, which was 2x plus h minus 5, and now I would have taken the limit. If you notice here, I just kind of threw everything in line, did it all at once. You can do it either way. I don't care which way you do it. The more advanced students typically like doing it this way, where it's all at once, and the students, other students who want to take their time and really understand it, break it down into those steps, and I encourage you doing it that way if you're more comfortable with that. Okay. So what I want you to notice is that every single step I've been putting my limit as h approaches 0 because I have not evaluated the limit. Now I'm actually going to evaluate that limit. Because I'm evaluating that limit, I'm going to plug in 0 for h, and I no longer write the limit as h approaches 0. So this would be 2x plus 0 minus 5. So the only time that I could get rid of that limit I've been writing every single time is when I actually plug in for that limit. So what do I end up with? I end up with the answer, which is 2x minus 5. So there's finding the derivative, doing it all at once. If you want to see how to do it separately in parts, go ahead and look at the posted solutions. The posted solutions do it in that 4-step process instead of all at once. I hope that helps you out.